Good afternoon. It's officially afternoon, right? Well, it will be in like 30 seconds. I heard the clock tower, so I figured it was noon. My watch says it's 11:59, but we'll go ahead and get started. My name is Mike Coleman. I'm a developer advocate at Sysdig. Sysdig is a cloud container and Kubernetes security company. I actually work on the open source ecosystem team, so I focus exclusively on open source technologies, and more specifically on a project called Falco, which is what I'm going to talk about today. Just curious, how many of you have heard of Falco? This is the general response I get, like 2% of the people. How many of you in the audience are actually tasked with security in your organizations? Like that's what you do, you're security people. How many of you are platform administrators? And then how many of you are like developers? Anybody in management or marketing? Okay, I'll talk really slow. No, I'm kidding. I was in marketing once upon a time too, so standard joke. Sorry, you're the butt of it. Okay, so I didn't give my background. I came to Sysdig about a year ago. Prior to Sysdig, I was doing developer advocacy at Google for Google Kubernetes Engine. For Google, I was at AWS, where I worked on easy cloud solutions, including easy cloud container offerings. Before AWS, I spent 3 years at Docker. I was evangelist there, predominantly evangelizing the commercial products, but also a lot of the open source stuff as well. Prior to that, I was at Puppet, which is where I started in open source doing config management. And prior to that, I was at VMware. I was also an IT architect and other stuff before that, but I go back that far because that sort of is how this talk is structured, is about the difference between how you used to secure things and how you need to secure them now in the cloud native era. So, you know, back in the day when I first got started and I was actually using physical servers, if you said security to someone, they would say it's a firewall, right? It's a perimeter. If you're securing a building, the first thing you might do is build a fence around it to keep people out. And that was really good for a long time. And that was sort of the, that was sort of the benchmark. Okay, we got a firewall. We're protecting from intrusions. If we know if there's a breach, we know we've got a problem. And that works really well with the defined perimeter, right? There's some other things that you could do to secure a building. You could issue a key card, right? And that key card could be associated with certain permissions. So with that key card, I could go in and I could tap on a door and either get into the server room or not get into the server room, get into the research lab or not get. So that was authentication and authorization, right? In a physical building. And those sort of ideas become super important when you move into an environment where you don't have any boundaries, right? Where all of a sudden, everything you do is exposed to everybody else potentially, right? So if you've never done it, go on to any public cloud provider, throw up a VM instance with a public IP address and see how long it takes for people to start scanning that IP address to see if you're gullible, if you are available to them. It's a matter of seconds. And I will not ask you to admit anything that I haven't done before. How many of you have put your public, your like AWS or Google Cloud or Civo credentials on a public GitHub repo? Ever? I have done that. No one else. Me and you were the only honest ones in the whole audience. How many of you have ever over-provisioned something like an S3 bucket and said, you know what, just make it easy? I don't know, there's a guy on the internet named Corey Quinn. Anybody know Corey? He talks about cloud stuff and he has about 100,000 followers. And one day he puts this up. He said, who's the idiot who wrote this tutorial for AWS? And I was like, it's me, I'm the idiot, I wrote it. Because I had said, like, you're going to install this plugin and we're just going to give the S3 permissions full access because that's what the plugin needs and we're just going to do it. And I was like writing the thing and I was following the documentation of the company that made the plugin and that's what I put up there, right? And I should never have done that, but I did it anyway. Why did I do it? Because S3 has like 53 permissions on it and I didn't know what the plugin needed to work appropriately, so I just gave it the full reign. So that's the other thing to think about. I've given this talk a few times in different permutations with different sort of links. And I had someone say to me in the audience one time, they're like, you know what? The most dangerous person in my environment is a disgruntled employee. And I said, that can be dangerous. But I think your most dangerous person in your environment is an overworked systems administrator or developer looking to take a shortcut because they have so much work to do, or making an honest mistake. Do you think I intended to put my credentials up on GitHub when I pushed them up there? No, I just forgot to remove them and they ended up there. So what we need to be able to do in this environment is not stop people. Well, you do. So you still need to stop people. You need firewalls. You need authentication and authorization. You need all of those things. You need shift left. You've got to scan for vulnerabilities, and you've got to make sure that you don't have any CVEs. And if you do have CVEs, do I really care? You should be using a distro list-based container image, all of that stuff. And all that stuff is great, but you also need to know what people are doing in your environment. So if we go back to the building analogy, and somebody tailgated their way into the building, they followed somebody in who had a card, and now they're in your building, how do you know what they're doing? What would tell you what they were doing? Security camera would do it, right? And so that's what you need. When you don't have a perimeter, or when someone has breached the perimeter, you need something out there watching all the time. So a security camera could be pointed at a door. It could use facial recognition, following on the previous talk, right? Use some AI to figure out, I don't know who this person is. They shouldn't be anywhere near this door. And it could alert you in real time. And that's what you need in your cloud environments. And that's what we talk about when we say runtime security, right? We just think about it as a security camera for your environment. So, but I just told you, I've got dynamic application security testing and static application security testing. I have a cloud internet and entitlement management system. I've got a cloud security posture management. I've done all of these things. You're telling me I don't need that? No, I'm telling you, you need that, but you also need to understand what people are doing and how do those patterns of behavior alert you to a potential attack. Right? So if you think about something like Log4j, that vulnerability was 10 years old before it finally got taken care of. It sat there nascent until somebody found a way to exploit it, and then they did. So in 2013, and I'm sure nobody was doing this, but you scanned your images, you did all that stuff, and you're like, oh, I'm golden. And then 10 years later, you find out you're not. It doesn't have to be 10 years later. It could be the next day. So you deploy something into production and you're like, this is great, man. Scanned it. I'm running Wolfie, distro list, Harbor, Quay, whatever you're doing. You're doing trivia, whatever you're doing all this stuff and you're scanning it. And then the next day somebody decides to do something because they're in a rush or they make a mistake. And that's where you need to look at things like, what's the behavior? What's the pattern? What are people actually doing in your environment? So to do that, in cloud and container and Kubernetes environments, we recommend something called Falco. So Falco is an open source project that was created by the founder of Sysdig, Loris Degioni. I think that's how you say his name. He'd probably tell me no, but I think it is. And it's basically an engine that does detection for you. So we've got about 6,700 stars on GitHub, and we've had about 100 million downloads across the Falco ecosystem of the project. We are a CNCF incubating project. We were the first runtime security project in the portfolio when we joined in 2018, I think. The project started in 2016. We are very close to graduating, very, very close to graduating. So hopefully that happens in the near future. So what Falco does is we look for events coming in from a variety of sources, and I'll dive into what those sources are and how they work. And we bring them into a rules engine. And the rules engine, we'll talk more about rules. But anyway, events come in, we compare them to rules, and then we alert you of suspicious activity. So the first way we do that, the most basic level, generic Falco out of the box, we use a kernel module or a eBPF probe as a driver that sits in the kernel. So that they sit over here, the driver sits in the kernel, and it is intercepting every system call that's being made on the Linux host. So for those of you who don't know, system calls are basically the lowest level primitive of how code gets executed. So you write a method, or you write a function or whatever, and you say read a file. Well, that's going to use a read system call, it's going to use an open system call to open the file, then a read system call to read the file, and all of that. So system calls basically control everything that happens in the operating system. And by putting those in the kernel, we can not just interpret what's happening on the host, but we can also take what's happening in the containers, because all containers are isolated Linux processes that send their system calls down to the kernel of the host on which they are running. We can capture that and we can evaluate those. All of those go onto a ring buffer. And a ring buffer is just a memory construct to store information. And it's not super important except for me to say that the system calls are immediately placed on the ring buffer. So it's a non-blocking operation that does not affect system performance, right? So as soon as system calls come flowing through, they get dumped onto the ring buffer and they sit there and the kernel doesn't have to do anything else with them, because in user space on the node, we have got the daemon running. We have the Falco daemon. The Falco daemon is going in, it's pulling things off of the ring buffer, and then it's taking it in and it's evaluating them against the rules. And, we'll talk about what these things mean in the next few slides, but it's looking at them. Did I violate a rule? Yes, I got a format output. Let me grab some metadata and let me send that out to either standard out, syslog, or HTTPS or gRPC endpoints. So at the end of the day, what it does is pretty simple, a little more complex behind the curtains, but capture these system call events, throw them into this engine, and then send out an alert. I don't know. The ring buffer size could be dynamic. It's set initially for you, but it can be set. You can set the size on it. Kernel modules versus eBPF probe, for those of you who are wondering. eBPF is your preferred way of going because it works across more environments. You just have to have a more modern kernel to do it. So if you got a kernel 5.1.8 or later, that's what you want to do. Like I'm going to do my demo. I'm sorry, Civo. I'm going to do my demo on Google Cloud because I already had the environment built. But in the case of GKE, you have to use the eBPF probe. You can't use the kernel module because Google doesn't let you install kernel modules onto your nodes. The thing is, use the eBPF probe until you can't. All right, so Falco ships with about 80 different rules, and we have these rules broken up into sort of like production level, incubating rules, and sandbox rules, kind of following the same CNCF hierarchy. And it's about 30, 20, 30, something like that in those rules. They are basically looking for things that would constitute either suspicious or anti-patterns. So did someone shell into a container? Is somebody running netcat in a container? Did somebody try to rename a file? Is somebody running a package manager in my environment? All of those things. So if those things are happening in the back, then we can let you know about it. The rules are all up on GitHub. In the longer version of the talk, I actually go out and show you more of the rules, but I'll just give you an overview here. So this is a Falco output message. And so you'll see here that you get the overarching message, which is a shell was spawned in a container with an attached terminal. And then remember I talked about like the metadata and the enrichment? That's what all of this is, where we get the login ID of the person, the ID of the container, the name of the container, what shell did they run, what was the actual command line that was executed, the terminal ID. All of that stuff comes because not only are we hooking into the system calls and we can get all the OS information, but we also are hooked into the container runtime and we're hooked into the Kubernetes API server. So we can triangulate all of that data. And that whole process is actually really kind of cool how we do it. We use in-memory state tables that get updated dynamically. I have a whole video on YouTube about that process. It's called Enrichment if you want to learn more. Not enough time in a 25-minute talk for it. So as I said, you have system calls, they come in, but people operate across different and, with more than just the base operating system. So we do take Kubernetes audit logs. We also take logs from Okta. We take logs from CloudTrail. We take logs for Google Cloud logging and GitHub, and that's all done through a plugin architecture. So if you wanted to, you could think of anything that streams. Twitter streams data in a known format. So if you have a stream of data in known format, you can write a plugin and send that to the Falco events engine. So you could write it like, I love soccer. I live in Portland Timbers, follow them religiously. Their owner was notorious for spouting off on Twitter and then deleting his tweets before people could see them. So my friends and I wrote a program to capture all of his tweets and archive them and then repost them as images. Right. You could do that with Falco, right? Falco would be one way to do that. We just did it by writing like a node program, but you could say, okay, I'm going to write a Twitter stream, and if the username is Merritt Paulson, then send me a critical alert that he's spouting off on Twitter again. So, anyway, and then I talked about HTTPS gRPC standard out, but we also have something called Sidekick. And Sidekick allows you to take and extend the output of Falco into about 60 different environments. So this is nearly unlimited if you want to write it. Right now, there's about a dozen of these plugins, and there's about 60 different outputs. Now, no one's asked the question yet because I haven't actually stopped to breathe the whole time I've been talking, so no way you could get a word in edgewise, of course. But if I say detection to you, what is the next? If I say peanut butter, what do you think? Jelly. If I say detection, what do you think? Anomaly, that's a good one. What's the other one? Response, right? Detection and response. So all we've talked about today is detection, because that's what Falco does. But someone says, I don't really, like, so you told me that somebody did something. What are we going to do about it, right? And that's where Sidekick can come in. So Sidekick allows you to either forward your events into, let me see what I got this one. Forward your events into a variety of different environments where you can take action then. So in my demo, I'm going to, and yes, there is a demo, and I don't know how I'm going to do it with a handheld mic, but we're going to make it work. In the demo we're going to do, I'm going to send that information out to Slack as just a real quick example. But you could, right? You could send it to PagerDuty for alerting. You could write it all out to a bucket in the storage systems. You could send it into a metrics platform, Datadog, Prometheus, whatever. You could send it over to a functions as a service platform, right? So you could send it over to OpenFaaS, and you could take so someone shelled into a running container. I got an alert. I send that to OpenFaaS. OpenFaaS looks at what the container ID was, or the pod ID, actually is what it would look at. Looks at the pod ID, and it labels that pod, or the container in the pod or whatever. And then it labels it, and that tells Kubernetes to take that pod out of commission, and then we restart it. Right. And so that would be like a remediation stream. We also have a couple of very nascent projects going on. One is called Talon, and that will allow you to build remediation without having to use a third party. You won't have to write your own function on OpenFaaS. And the idea there is to provide, a set of basic tools to do that. And then the other one is called, wow, I really want to, super, what's the word I'm looking, original name. It's called Falco GPT. So, yeah, okay. So trying to train an AI model on, like, when we see these type of behaviors, what are we looking for? Because the problem is that an attack is not one simple thing. Somebody may have shelled into a container for very legitimate reasons, right? And it's possible there's a legitimate reason that they ran a package manager, installed new software in a running container. Little less likely. Is there a good reason for them to install Netcat? Maybe not. Or SSH daemon? Probably not. So it's those steps. So how do you correlate activity to make all of that, so that you can take action on it? And that's what they're trying to do with Falco GPT. Now, somebody had to pay for my flight. Somebody had to pay for me to be here. So this is the 30 seconds of commercial. So that, of course, is what we do with our commercial offering at Sysdig, right? Falco is the core agent running under our platform Secure, but the platform is built to handle all of this stuff for you. So that's all I'm going to say about it. That's all I can say about it because I don't work with it. But it's good. So, all right. And so, like I said, you can use Falco to send a notification to some sort of compute platform or continuous delivery pipeline to take some sort of action, and then use that for remediation if you want to build those pipelines. So I spoke to somebody yesterday who has a very young startup, and they're like, we're doing everything self-hosted, cloud native self-hosted. They may be in the cloud, but they're not using any they don't use hosted services. They don't use GKE or EKS or whatever. They run vanilla Kubernetes up there. And so, this is that type of person would probably want to use this type of setup. Right. Anyway, so yeah, that is my time. That is my demo. I don't know. I probably have a slide that says, hey, I do have one slide. I'll just pull it up real fast. I'll go over here. Chrome, you scare me. There we go. And then we go here. Yeah, I just put this up here because GitHub, Falco Security, falco.org. We have a channel on the Kubernetes Slack where you can find us at #Falco. We do weekly community calls, and we're on LinkedIn as well, so you can find us there. If you have more questions, I'm going to stick around and take them. But thank you very much to Civo for having me here. Thank you all for attending. I hope you found it useful. If you have any questions, come up and talk to me, and we'll do that.